So for this unit, we are translating algebraic expressions. We're going to be given phrases and we will then convert them into mathematical operations. So let's get started with some of the basics that we've seen. So we've heard of words like sum. We've heard plus. We've heard a phrase more than. And I think for all of those, when we see those, we immediately think we add. So if I have the sum of 2 and 8, I know that I'm taking 2 plus 8. If I were given 2 more than 8, that's telling me to perform the same operation, and they both simplified to 10. Then there is the inverse of that, which is the difference. So we've also seen a phrase less than when we're referring to that. And when I have the difference, mathematically, that symbol means we're subtracting. Now, I want us to be mindful of this one because we're going to do a couple of different examples using that, and the order in which we do it matters. So for example, if I were asked to evaluate the difference of 15 and 3, if I want the difference of 15 and 3, we know that we are subtracting, and that would be 15 minus 3, which would simplify to 12. But if I were given this phrase, 3 less than 15, and we're going to see this in the next slide, less than. So when we see the then part, that is what's referred to as a turnaround word, which means I'm going to take those two and they're going to swap places. So that would actually be 15 minus 3 again. Because if you had $15 and I had $3 less than you, then I would have $12. So that's a turnaround word, which means those 2 points, those 2 values, get flipped in my expression. Now the next operation that we will see is the product. And another word that is synonymous with that is times. And when we think about that notation, that symbol would be multiplication, or the little dot. And that means that we're going to take the product. So our example, the product of 6 and 2 is 12, which is the same as 6 times 2. Which then takes us to its inverse operation, which is the quotient. And another phrase that we use is divided by. So what comes to mind when you're thinking of that? You're thinking division. So we would say the quotient of 20 and 5, and that would be 20 divided by 5. The quotient of 20 and 5 would be 20 divided by 5. So let's look at this table of different phrases and examples and see if we can't fill these in. So for the first one, the phrase, I'm looking here, is a number. When we have an unknown, so when they're just giving us this generic number, we have to then assign it what we refer to as a variable. And that variable can be any one of the 26 letters in the alphabet, X or N or whatever you want. So when we have this example, 5 times a number, we could write that as 5 times X. We know that we're taking the product, or just 5X. Standard is that the number usually comes before the variable. So next one is sum, and we know that symbol is plus, we're adding. So if I look at this example, the sum of, so I know I'm adding a number, so I don't know that number. I'm going to put a variable in its place as a placeholder. and 3. This is telling me the sum of a number and 3, n plus 3. So on to this one. Difference, we know we're subtracting. And the way this is phrased, the difference of a number and 9. So there's my number, and I'm subtracting the difference between that number and 9. Here we go. So now we've got product, which we know is multiplication. So the product of 6 and a number would be 6p. Taking us down to this one, quotient. We know that we're dividing. The quotient of a number, so we're dividing. So let's say this number is m and 12. Now this one's useful. When I see of, I also want to think that's multiplication. So if I have 1/4, that's 1/4 of a number, I know I'm multiplying those two. 1/4 of a number. And that last one is, that symbolically means it's equal to. 2 and 3 is 5. So in this example, we have 2 times a number. So there's our unknown. So 2 times a number. So I'm going to say 2x. That's 2 times a number. Plus 6 means equals 14. And then these last two, which we refer to as our turnaround words, which is helpful here. Whoops. So then is one of our turnaround words. 6 less than a number. So I have the number 6, and then I have this unknown number. I'll call it n. So it's less than. That means I'm taking 6 away from that number. That means I'm taking 6 away from that number. 6 less than a number n would translate to n minus 6, because I have a number and I want 6 less than that number. And then another one is from. So if we have 10 subtracted from a number, we would, let's call that number b. So there's b, and here's 10. So I know that this, I could either translate as 10 subtracted from a number b, or I could say 10 less than that number. So let's try doing a couple of these where we have combined operations. So looking at the first one, we're asked to find twice a number and 10. So I start with this. What is twice a number? Well, this is unknown, so I'm going to call it x, and I'm taking twice that number. So that's twice a number, and means I'm adding 10. So that would translate into 2x plus 10. So let's look at the second. 3 less than 5 times a number. Think about what we're doing here, and think about what that trigger word is. That's a turnaround. So I'll start maybe with this piece. I know 5 times a number is 5 and x, and then this is 3. And because that's a turnaround, I know that that would be 5 times a number, take away 3. And this expression would read 5x minus 3. All right, looking at the third one, what are you thinking here? The sum of, so I know I'm adding. What am I adding? I don't know. The sum of twice a number, so we know what this is, twice a number, and 11. So that gives us 2n plus 11. So, what makes that different than this? Twice the sum. So what am I taking twice of? The number? No, the sum. So let's look. The sum of what? So let's figure out what that sum is in this problem. The sum of a number and 11. So now I have a number, I'll call that x, and 11. I have a number x and 11. And what do I want to do with that number? That's what I want to double it. I want to take twice that sum. So I want to put that entire quantity, because that's the sum of a number and 11, and I want to double it. This is twice the sum of a number and 11, which is different than the previous. Okay, let's look at the next one. 3 times, so that's 3 times the difference. So now 3 times what? Not a number, but 3 times the difference. So I know it's going to be 3 times the difference of what? The difference of a number, I don't know it, I'll call it y, and 4. So difference means y take away 4, and that's my difference, and then I want to triple it. So that expression, I'll write it so that it would look like so. 3 times the difference of a number and 4. Okay, and let's look at the last two. 8 less than, I'm flipping, that's a turnaround, twice the difference of 7 and some number. Okay, so twice what? Twice this, the difference of 7 and some number. So twice the difference of 7 and some number. So what we have in green highlighter is what we have expressed there. Twice the difference of 7 and some number. And what do I want to do? I want to take 8 away from that, because we're saying what this expression is 8 less than that. And it's a turnaround, the than. So that leaves us with this expression. And lastly, 1 more than, which means I'm going to do some business in the front, but I know I'm going to add 1 to it. The product, now I'm multiplying here, right? The product of what? 3 and the square root of a number. So the product of 3 times the square root of some unknown, so that's my variable, and I would leave it just like this. And I hope what you're identifying with all of these so far is that we have been dealing with expressions. Expressions are just numerical values that don't actually equal anything. So this is an expression. 2 times x plus 1 is an expression. And what we're going to do later is we're going to translate these, and we're going to start working with equations, which is when I have 2 sides, I know that this is going to equal something. This, when it's got an equals, implies now I have an equation. I have a left side and I have a right side. We're going to have equations where we're going to say, well, this equals 84. But for now, we are just translating these into algebraic expressions.